Hello everyone, this is Deepashri. Today I am going to discuss one of the most important topic for JEE mains and advanced point of view, that is phenols. First we discuss about the structure of phenols and general formula. The general formula is having C6H5OH, and where the phenol structure is having the hydroxyl group which is directly attached to the benzene ring. Here you can see the structure of phenol which is having the hydroxy group directly attached to the benzene ring. There are other classifications for phenols like dihydric and trihydric phenols, which can be formed from when the hydroxy group more than 2 attached to the phenol, which leads to the formation of dihydric and trihydric phenols. There is an example for dihydric phenols like catechol, resosinols, and phenols. For trihydric phenols, 1, 3, 4 benzene triols. This is the basic introduction for the phenols. Firstly, we will know about the difference between the phenols and alcohols, because in alcohols there is a hydroxy functional group, and in phenols also there is a hydroxy functional groups. Why the difference occurs between the alcohols and phenols? The basic difference occurs due to the phenols which is having the hydroxy group which is directly attached to the benzene ring, which is resonantly stabilized by the resonance structures, where the phenoxide ion which is formed which is acidic in nature but not in alcohols. This is the basic introduction. Let's discuss about the methods of preparation of phenols. Phenols can be prepared from haloarines. Let's take chlorobenzene. When this chlorobenzene reacts with NaOH at 123 Kelvin and 300 atmospheric pressure, which leads to the formation of this phenoxide ion called sodium phenoxide intermediate. When this reacts with HCl, which gives to the formation of phenol. This is the first preparation of phenol. There are other preparation of phenols. Let's discuss that also. We can prepare phenol from benzene sulfonic acid, where when benzene reacts with oleum, which is having the composition of H2S2O7, which leads to the formation of benzene sulfonic acid. When this benzene sulfonic acid in presence of acid and base, which gives to the formation of phenol, we can use NaOH and H plus from acid and base. Let's discuss about the another most important preparation of phenols from diazonium salt. When aniline reacts with NaNO2, sodium nitrite, and HCl, which leads to the formation of benzene diazonium chloride, which is a salt intermediate. When this benzene diazonium chloride reacts with water vapor, it gives the phenol. Here you can see the byproducts, nitrogen and HCl. Nitrogen can be easily eliminated as a gas, so we can easily obtain the phenol from this. So this is the best method for preparation of phenols, we can say. And we can prepare phenols from cumin also. The cumin, which is having the isopropyl group, which is directly attached to the benzene ring. When this cumin reacts with oleum H2S2O7, which gives to the formation of cumin hydroperoxide. This cumin hydroperoxide, when reacts with acid, water, it leads to the formation of phenol and acetone, which as a byproduct. This is the basic methods for the preparation of phenols. Let's discuss some of the physical properties of the phenols. Pure phenols are generally colorless, usually solids or liquid in nature. The light color of phenols appears due to the oxidation of phenol by air in presence of light. This is about the state of the phenol. Let's discuss about the others also. Like phenols are generally insoluble in water, but take the polyhydroxyphenols, which are generally soluble in water, because there is a formation of intermolecular hydrogen bonds in the polyhydroxyphenols. Due to this intermolecular hydrogen bonds, there is a high boiling point for phenols when compared to the other hydrocarbons or aryl halides or any compounds. Let's discuss some of the other physical properties also. And as I told before, there is a acidic nature of the phenol occurs compared to alcohol because of its resonance stabilization. This is the resonance structure of the phenol you can see. There is a OH group which is attached to the benzene ring. In that, O is having the lone pair of electrons which delocalized into the benzene ring. When this lone pair of electrons delocalized into the benzene ring. There is a dislocation of the one of the bond from the benzene ring to the adjacent carbon takes place because there is carbon which is having the valency of 4. It cannot hold more electrons than 4 bonds. So there is a dislocation of the bond takes place to the adjacent carbon. This takes place in a cyclic manner. When this bond dislocates, these electrons in this position there is a negative charge, then this negative charge is shifted to the next position, and then this bond is again dislocated to the carbon, and this takes place in a cyclic manner which leads to the resonance hybrid. Here you can see the phenol which can easily give H plus ions which leads to the formation of phenoxide ion. This is the basic resonance structure for phenoxide ion. Let's discuss about the chemical properties of phenols. When phenol reacts with dilute nitric acid, which leads to the formation of ortho and paraphenols. Here you can see in resonance structure. See, there is an electron rich in second, fourth and sixth position. This is ortho and this is para and this is ortho. This is the electron rich site. So electrophiles can easily attack on electron rich site of the phenoxide ion. Like this, here you can see the nitration where phenol reacts with dilute nitric acid which leads to the formation of orthophenol and paraphenol. And then the phenols when reacts with concentrated nitric acid which gives 2, 4, 6 trinitrophenol because the electrophile which is generated which is a strong nature in this. Let's discuss about the halogenation of phenols. When the phenol halogenated in presence of Br2 in CS2 at 273 Kelvin which leads to the formation of orthophenol and paraphenol as as I said before in the nitration. And there is another method also. As I said before, there is a formation of ortho, para, ortho, like two ortho positions are also separated from bromine and one para position also separated from bromine electrophile because this bromine electrophile which is strong electrophile, so the formation of 2, 4, 6 tribromophenol takes place when phenol reacts with bromine water. Let's discuss one of the most important named reaction called Kolbe's reaction. When phenol reacts with NaOH, which leads to the formation of sodium phenoxide. When this sodium phenoxide reacts with CO2 in presence of acidic medium, which leads to the formation of salicylic acid. Here you can see the reaction for Kolbe's. Let's discuss about the mechanism of this reaction. When this sodium phenoxide, which is having the lone pair on oxygen and Na having the positive charge, O is having the negative lone pair of electrons when reacts with CO2, which is having resonance form, which leads to the formation of intermediate. When this intermediate undergo tautomerization which leads to the formation of this sodium salicylate. This is the sodium salicylate structure. When this sodium salicylate reacts with H3O plus which leads to the formation of salicylic acid. This is the most important reaction that can be asked in your exams. And another most important reaction is Riemann-Tiemann reaction. What is this Riemann-Tiemann reaction? When this phenol in presence of chloroform and aqueous sodium hydroxide which leads to the formation of the same intermediate as Kolbe's reaction, that is sodium phenoxide intermediate. When this sodium phenoxide intermediate reacts with NaOH which leads to the formation of sodium intermediate along with the aldehyde which is attached to it, which when in acidic condition when this intermediate also like the product reacts with acidic environment which leads to the formation of salicylaldehyde. This is the Riemann-Tiemann general equation. Let's discuss about the mechanism. Let's say this phenoxide ion when reacts with chloroform. Here you can see one of the most important thing. where NaOH when reacts with CHCl3 which leads to the formation of free radical which is the electrophile called dichlorocarbon. This is previously asked question, you have to remember this, that is the intermediate for Riemann-Tiemann reaction, that is dichlorocarbon, and NaOH and H2O is released as a byproduct. When this dichlorocarbon reacts with this phenoxide ion, leads to the formation of this structure. When this leads formation treated with H2O, and there is a dislocation of the bond, which leads to the formation of this, and there is a another hydrolysis reaction which leads to the formation of this salicylaldehyde ion. This is the basic mechanism for the Riemann-Tiemann reaction. Here you have to focus on this dichlorocarbon, and one of the more important thing is why the aldehyde which is attached to the carbon only but not oxygen, because carbon is the most electron rich center in the benzene which is also stabilized by the resonance. So this aldehyde group which is attached to the carbon of the benzene ring but not oxygen. And if there is a substitution for para position, what reaction will take place? Means when there is a substitution for phenols in the para position, when it reacts with sodium hydroxide and chloroform, which leads to the formation of cyclohexadienones. Here you can see the cyclohexadienones. And then if there is a substitution in ortho position, what will happen? There is no formation of salicylaldehyde, and when these Riemann-Tiemann reactions takes place for the substituted ortho position of the phenol, where the product form the aldehyde group which is attached to the para position of the product. This is the Riemann-Tiemann reaction you have to see. There is a Lieberman's reaction. This is not that much important, but still you have to read. When phenol is treated with sodium dissolved in concentrated sulfuric acid, leads to the formation of red colors cell precipitate appears which changes to the blue on addition of the aqueous NaOH. This reaction is called Lieberman's reaction. This structures is not important, but still reaction just go through once. And the reaction of phenols with zinc dust. This is important. When phenol reacts with zinc dust, it gives to the formation of benzene. This is the reaction where phenol reacts with zinc dust, which leads to the formation of benzene and ZNO as a byproduct. This is the basic named reactions and the reactions of phenol. Let's discuss about the oxidation of phenol. Oxidation of phenol takes place in presence of sodium Na2Cr2O7 and acidic environment, which leads to the formation of benzoquinone. This is the one of the main basic oxidation reaction of the phenol. Let's discuss about the one of the most important thing why we study these phenols preparations and all, because there is a preparation of aspirin from the phenol. Let's discuss about the preparation of aspirin. When this phenol reacts with NaOH and CO2, which leads to the formation of sodium salicylate. When this sodium salicylate reacts with water in presence of acidic environment, which leads to the formation of salicylic acid. This I already discussed in the Riemann-Tiemann reaction. When this salicylic acid, which reacts with the acetyl chloride in presence of acidic medium, which leads to the formation of aspirin, which is the main important drug for pharmaceutical purpose that we consume. There is another reaction called esterification. When phenol reacts with same as I told here in the preparation of aspirin, when the acetyl chloride reacts with phenol, which leads to the formation of phenyl ethanoate and hydrogen chloride as a byproduct. This is the most important preparations of phenols and reactions of phenols. This is the topic. Then there is a points to be remembered, which is main like a route map for your JEE mains and advanced. For the exam point of view, there is a preparation of phenols as I discussed briefly about this before. Just go through this one. and this is the reactions of phenols where it can react with so many compounds and form the drugs as I told before, like aspirin, and there is a esterification reaction of phenol, Raymond-Taman reaction. These are all there in this, and this is about my topic of phenol. And thank you one and all.